series circuit specifically for this moment. Okay, so we said in a series circuit, how do we know it's series? First of all, the resistors are connected in series with one another, not the batteries. Okay, the batteries are also in this case, but we don't. If we say series circuit, we mean what? How are the resistors connected? All right. Okay, so if we speak about a series circuit, then we say the resistors are in series. It's outside. Okay. Yes? All right. Thank you, great teens. Calm down. Right. Then, when a circuit is in series, then it means that this current is the same everywhere. Okay, so the current is the same everywhere, but the volts splits up. Okay. All right, so let's look at the circuit. They say consider the circuit, so we look at it. So you take your highlighter and your little men walk. When they get to the 2 ohms, everyone must pass through there. Everyone must pass through the 4, everyone through the 12, and everyone through the ammeter and back home. Okay, so the current is the same everywhere. So what I want to write down there at the ammeter is I say the current that goes through there is the total current. The total current passes through the ammeter. It did not split up anyway. Oh, shh. It's at the primary school they're talking to the kids. All right. Then we have our volts there, our 6 volts. Okay, so like you have 6 sandwiches and you have to split them up. Some of the sandwiches goes here, some of the sandwiches goes there, some of it goes there. So the sandwiches will split up. Will the sandwiches split up evenly? No, because the resistance are different, right? For science, you need more sandwiches than you need for aloe or whatever. Okay. Now they ask, calculate the reading on the ammeter in the circuit. So I have an info table for myself. They ask the reading of the ammeter. The ammeter measures the current. Temple, what is the symbol for current? They ask for the reading on the ammeter. No, not V. V is work, yes? I is the current. Okay? So they ask for the reading on the ammeter. There's the ammeter. It measures the current, specifically the total current. Sharp? So that's it, the one. So if we need to calculate the total current, we want the total volts for that. And we want the total resistance. Say again? I have no idea. Maybe. All right. So, Kutlano, what is the total volts for the circuit? 6 volts. And Siyabonga, what is the total resistance for the circuit? Yeah. How did you get to 18? Don't worry, when it's your question, you also panic. So we give him his time. Yes, Siyabonga? Yes, the sum of the resistors, resistance. So 2 plus 4 plus 12. So I'm just going to make a note here. The total resistance, because they are in series with one another, you just add them together. You're going to say 2 plus 4 plus 12, and that gives you 18 ohms. So that is 18. Yes. Sorry? When what? Why are you going to minus? Nee, you minus niks. 12? Nee, don't. You can, so, Khali made a very important mistake, and a lot of you will make that mistake. He wants to, I don't know for what reason, I think the total current, he wants to minus the volts. Are you allowed, let's say you have 16 apples. What will your answer be here? 22 what? But it's not all apples. Okay? So very important. You can't add things together that are not the same thing. So you can't say 18 ohms minus 6 volts gives you whatever amperes. They're different concepts completely. Okay? You can't do that. You can't subtract or add them together. Just the same things, but what you can do is you can divide or multiply. Why? If you go to this formula here that you've seen before in technology, right? Last year? Yeah. Okay. Then we have from that formula resistance is volts over current. Okay. I want to get the current. The volts is 6 and the resistance is 18. Okay, so we have 18. All right. But now we have a problem. Because the thing that we want to calculate is at the bottom of the fraction. And we want it to be at the top. I don't want to get blah, blah, blah is equal to 1 over current. I want the current, not 1 over current. So how am I going to get rid of that or solve that problem, Rory-san? But if you take that 6 to the other side, then you still have 1 over, because that doesn't go to the top automatically. What are you going to times? By what? To get 6 away, you must divide. But you still have a problem. If we have, just wait a minute. If you have 20 is equal to 2 over x. What is x? How? No.
Ma'am, we don't know the value of x.
That's what we want to determine.
So for you, like, to what? Can't you calculate the value of x on the other side also?
Yes.
So that they are equal again, ma'am.
Yes.
Yes. Then when you divide x the other side, it will.
Guys, this is grade 8 mathematics. No, you did not. No. Moa, your hand was up. Yes, but we still have a problem of the x being at the bottom. How do you solve that problem of x being at the bottom? How? How?
You take the x, then you take the x.
Wacht.
You take the x, then on top.
How?
And you make the 2 a negative 2.
Rory-san. Yes, yes and no and yes. Okay? There's a few methods that you can do here. If, ladies and gentlemen, you have one term on the right hand side and one term on the left hand side, meaning you don't have a plus 2 blah blah blah, one term, then you can crisscross as much as you like. Alright, so since I is at the bottom there, I can take it to the top, and the thing at the top I must take to the bottom. Huh?
But look, if you take, you see now, you might let's say this one.
What say you?
I said, if you take the top, what is this? The eye on top, then, and you bring the 6 to the bottom.
But then you must do that on that side as well, ne?
Yes.
As you do on the one side, you do on the other side.
Yes.
So you can't say 18 over 1 is equal to I over 6. You can't say that. If you swap on the one side, you must swap on the other side.
But if you say negative,
No negative. It becomes negative if you have 18 is equal to I plus 6, and you take it to the other side, it becomes negative. Yes. Ja, kom vandag naar mij toe. Did you write this down now?
no.
Wat heb je gedaan? Ja. Oké. Zal je die woensdag of donderdag gaan spelen?
Ja,
Oké, zeker. Je hebt niks aan school aan.
woensdag.
Is donderdag schrijf je weg?
Ja.
Oké, alright, so je kan woensdag spelen.
Ja.
Kijk, net wel ook voor het. Oké, dankie meneer.
Je was weer daar.
Ja, laat ons eerst jullie uitspelen, want je ruim moet mooi wees. Dat hij was met groen gegaan. Oké, dankie. Right. Now we're going to look at resistors in parallel. We're going to do lots more calculations. Hey, shh. Right. So when we have resistors in parallel, what did we say about the current? The little man that walks. We see that the whole current must pass through that ammeter. They haven't had a choice to split up somewhere. Alright? So there we have the total current. And then the current has a choice. Either it goes through there, or it goes through there, or it goes through there. So here the current splits up into 3. Oopsie. 1, 2, 3. It's like you have a choice between, what is your choices? Geography, accounting, or EGD. Okay, but imagine you had. Alright, so you have 3 choices there. Alright, so the current splits up into 3. And then afterwards, after they've gone through everything, they come back together again. So we can see there that the current splits up. The total current there splits up into A1, A2, and A3. So we say that resistors in parallel are current dividers, little main dividers. Where do the men go? Okay, or another way of saying is the sum of the current through the branches, we call this branches, is equal to the main current. Right, then if we look at the sandwiches, the volts, the energy. Let's say here you get 3 sandwiches again. Okay, now Courtney, you walk, and you chose accounting. How many sandwiches do you have before accounting? Shh. Each person gets 3 sandwiches. How many sandwiches do you have before accounting? Afterwards? Where are you going after counting? Are you going to geography? 0. Because afterwards you go directly home. So here we have 3 volts. Okay, wow, let's say you chose geography. There you walk. Before geography, how many sandwiches do you have? Afterwards? Okay. You're going straight home. So this is also 3 volts. And Retabile, let's say you chose EGD. There you walk. Before EGD, how many sandwiches?
3.
Afterwards? Okay. Yes. So can you see that the volts remains constant in parallel? Okay. So we don't say we have 3 plus 3 plus 3 that gives me 9 volts. No. Okay. It's the current, the charges that chose to go through there get 3 sandwiches each. These that chose to go through there gets 3 each, 3 each. Okay, so you can see here the potential difference over each branch is equal to the potential difference over the circuit. So it remains constant. Right, now if we get to the resistance. It's not like we said, alright, I had accounting and geography and EGD. You don't plan for 3 subjects for the day. You only plan for 1. So we can't say, let's say the resistance here was 2 and 4 and 6. We can't say the total resistance here is 12. Because you do not have to go through each and every single one. So when we have resistors in parallel, then we add them up a bit differently. Okay, so when we calculate the total parallel resistance, we add them a bit differently. The formula looks like this. Right.